Section 1.3, Topic 2, Separation of Mixtures. Because each component of a mixture retains its own properties, we can separate a mixture into its components by taking advantage of the differences in their properties. For example, a heterogeneous mixture of iron filings and gold filings could be sorted individually by color into iron and gold. A less tedious approach would be to use a magnet to attract the iron filings, leaving the gold ones behind. We can also take advantage of the important chemical difference between the two metals. Many acids dissolve iron, but not gold. Thus, if we pour our mixture into an appropriate acid, the acid would dissolve the iron and the gold would be left behind. The two then could be separated by filtration, a procedure illustrated in Figure 112. We would have to use other chemical reactions, which we will learn about later, to transfer the dissolved iron back into metal. Figure 1.12, Separation by Filtration. A mixture of a solid and a liquid is poured through a porous medium, in this case filter paper. The liquid passes through the paper while the solid remains on the paper. An important method of separating the components of homogeneous mixture is distillation, a process that depends on the different abilities of the substances to form gases. For example, if we boil a solution of salt and water, the water evaporates, forming a gas, and the salt is left behind. The gaseous water can be converted back into a liquid on the walls of the condenser, as shown in the apparatus depicted in Figure 113. Figure 1.13, Distillation. A simple apparatus for separation of a sodium chloride solution, salt water, into its components. Boiling the solution vaporizes the water, which is condensed, then collected in the receiving flask. After the water has boiled away, pure sodium chloride remains in the boiling flask. The differing abilities of substances to adhere to the surface of various solids, such as paper and starch, can also be used to separate mixtures. This ability is on the basis of chromatography, literally the writing of colors, a technique that can give beautiful and dramatic results. An example of the chromatographic separation of ink is shown in Figure 114. Figure 1.14, Separation of ink into components by paper chromatography. A. Water begins to move up the paper. B. Water moves past the ink spot, dissolving different components of the ink at different rates. C. The ink has separated into several different components.